Welcome to True Projects. In this video, we are going to explain about a project titled False Positive Analysis of Software Vulnerabilities Using the Machine Learning. The project focuses on dynamic application security testing, a technology employed to identify the visible vulnerabilities in web applications by utilizing the automated software scanners. Various scanners can scan URLs and provide reports on the security vulnerabilities. However, these reported vulnerabilities may contain false positives requiring further analysis to determine their validity. The process of analyzing and eliminating the false positive is known as false positive analysis. This analysis involves examining the multiple parameters, including the type of vulnerabilities, HTTP request and the response data, HTTP header values, HTTP response codes, cookie parameters, and authorization headers. To address this issue, the project proposes an approach that utilizes the machine learning model based on the historic data associated with false positive. By leveraging this historic data, the project aims to improve the accuracy of vulnerability identification and minimize the occurrence of false positives. The project objective is to enhance the accuracy of vulnerability detection in web application during the dynamic application security testing by addressing the issue of false positives. The objective is to propose an approach that utilizes the machine learning model trained on historical data associated with false positives. By leveraging this historical data, the project aims to reduce the number of false positives reported by automated scanners, thereby improving the overall accuracy of vulnerability detection. These are the basic requirements that are needed to build this project. Hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Scan Result. In this module, the scanner result data is uploaded to the system. The data contain web pages that have potentially injected with malicious code such as cross-site scripting and cross-site request forgery. And the second module is data cleaning. In this module, the raw HTML data obtained from the scanner result is processed and cleaned. The cleaning process involves removing the HTML tags, special characters, and other noise to extract the relevant test information from the web page data. And the third module is data modeling. This module focuses on converting the cleaned test data into a numeric vector representation. The test data is transformed using the count vectorizer class in Python, which convert the test into numeric ASCII values. The data set is then split into training and testing set for further analysis and evaluation. And the fourth module is Run Random Forest Algorithm. In this module, the random forest algorithm is trained and executed using the prepared training and testing data. The random forest algorithm is a supervised machine learning classifier that combines the multiple decision trees to make the prediction. It is utilized to classify whether a web page contains a false positive or a real vulnerability. And the fifth module is Run KNN Algorithm. This module involves training and executing the k-nearest neighbor algorithm. The KNN algorithm is a supervised machine learning classifier that assigns label to the new data points based on their proximity to the labeled data points in the training set. It is used to predict whether a web page is a false positive or a real vulnerability. And the sixth module is Run Decision Tree Algorithm. This module focuses on training and executing the decision tree algorithm. The decision tree algorithm is a supervised machine learning classifier that creates a tree-like model of decisions based on the features in the training data. It is utilized to predict the classification of web pages as false positive or real vulnerabilities. And the seventh module is Run SVM Algorithm. In this module, the support vector machine algorithm is trained and executed. The SVM algorithm is a supervised machine learning classifier that separates the data points into different classes using a hyperplane. It is employed to predict whether a web page is a false positive or a real vulnerability. And the eighth module is false positive prediction. This module involves predicting the false positives in web pages using the trained machine learning model. The test data, which consisting of web pages without labeled vulnerability information, is fed into the trained model to predict whether each web page is a false positive or not. And the final module is accuracy comparison graph. This module generates an accuracy comparison graph to evaluate the performance of different machine learning algorithms used in the project. The graph visually illustrates the accuracy of each algorithm in predicting the false positives. It helps to compare and assess the effectiveness of the model in differentiating the false positives from the real vulnerabilities. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder consisting of the test dataset and real dataset. And this is the machine learning test and test1 or the Python code file. And this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Scan Results button. By this, it redirected to the dataset folder. Here, we need to select this dataset and click on Open button. Here, we can see the dataset is offloaded and click on Data Cleaning button. By this, the data is cleaned on the dataset and view the web pages found in the dataset after HTML cleaning is of 2599 and click on Data Modeling button. By this, it converts the data into the numeric vector and split the data into the training and testing part. Here, the numeric vector size is of this and the data set is divided into training part and testing part as of training 2079 and testing 520. And then click on Run Random Forest Algorithm button. By this, the random forest classifier is generated by giving the accuracy of 99.6% and then click on Run KNN Algorithm button. By this, the KNN model is generated on the pre-processed data set with giving an accuracy of 87% and click on Run Decision Tree Algorithm button. By this, the decision tree model is generated by using the pre-processed data set with giving an accuracy of 99.6% and then click on Run SPM Algorithm button. By this, the SPM model is generated with the use of pre-processed data set with giving of accuracy of 100% and then click on False Positive Prediction button. Here we need to upload the test data set and click on Open button to get the false positive attacks. And here this scanner detected as the false positive. Here the total test HTML pages are of 15 and the total positives are 7 and real vulnerable are 8. Here this is of real vulnerable and this is of the false positive. And this way we can predict a false positive and the real vulnerable by using these various machine learning algorithms and click on Accuracy Comparison Graph button. Here in this graph, the x-axis represents the algorithm names and the y-axis represents the accuracy of those algorithms. From this graph, we can conclude the random forest gives an better, more accuracy compared to that of other algorithms. The project proposed an approach to eliminate the false positives in dynamic application security testing by using the machine learning model based on the historical data available on the false positives. The proposed approach is tested on two types of vulnerabilities that are cross-site scripting and cross-site request forgery, and the results show that approach can significantly reduce the number of false positives reported by automated scanners. The project concludes that the proposed approach can be extended to other types of vulnerabilities and can be used to improve the accuracy of vulnerability detection in the web applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.